All right, let's go ahead and get started with these. Let me grab my. There we go. All right, so when we are trying to take care of problems like this, remember combining like terms as a first step is super duper important. Here we've got x and 2x, so that makes 3x. We've got 3 and minus 1, so that's a plus 2. Then you've got 7x plus 2. Now, again, I always like to make sure that I start by getting the variable on one side. So, whatever. Let's take the 7x and subtract it over to the left. Here we're left with negative 4x plus 2 equals 2. Now I can take care of the numbers. I'm going to subtract 2 from both sides. 2 minus 2 is how much? 0, right? So when we divide by negative 4, and 0 divided by anything is just 0, right? So don't get confused. Remember, there must be a number on both sides of the equal sign of some kind, either whether it's a variable or a constant. And so if you go through here and you do something like this, 2 minus 2, you better have a number here. This would better be 0, right? Don't forget about that. It does make a difference in your answer. Some people get that confused. Now, with problem number 2, if you look, there's a minus sign in front of these parentheses. Unlike when there's a, so remember we said if there's a plus sign in front of the parentheses don't mean anything. Here, though, this is like saying 4x minus 3 plus negative 1 times this thing. So we're going to distribute a negative 1 in and rewrite it like this. Right? Because negative 1 times 2x is negative 2x. Negative 1 times negative 5 is positive 5. It's all still addition and subtraction. There should be no multiplication resulting here, right? So now we can combine our like terms. 4x and 4x minus 2x, you got 2x. 5 minus 3 is 2. And subtract the 2 because it's now we just got a normal two-step equation. Divide both sides by 2. You get x equals 5. All right. Let's go ahead and get started with our work today. So what are we going to do today? We're going to talk about 3 shapes, and we're going to go over a lot of sort of applications of them and using them to find variables and stuff like that. So we're going to go first parallelograms, then we're going to transition into trapezoids, and then we're going to end up with kites. All right. So a little bit about parallelograms. All of these things make a parallelogram. If you have one, then you have all of them. And if you have any of these, then you automatically get the rest for free. So if you're told, hey, you have a parallelogram, then all of these things are true. Both sides, both pairs of opposite sides are parallel to each other. Both pairs of opposite sides are congruent to each other. The angles that are next door to each other add up to 180. Like see here, the two that are the bottom right and the top right, they add up to 180. The bottom left and the bottom right, they add up to 180. And that would be true all the way around. Any two angles that are next to each other add up to 180. And that's because, if you've got the parallel lines, then same side interior angles add up to 180, right? And if the angles that are next to each other are always adding up to 180, then that means also that the opposite angles are congruent to each other. All right. So these 4 things are like sort of the most important. These next two we're going to talk about too, though. So this one's actually also super important. Whenever you have a parallelogram, if you look at the diagonals, like you draw corner to corner, opposite corners, they cut each other in half, right? And then this last one, so it's kind of like a combination of the first two. So if you have one pair that is both congruent and parallel to each other, then that's good enough too. You don't have to have both pairs of sides. You can just have one pair with both. So, first problem, I want to find what y has to be. And I want to point out something. They're going to ask this question in both directions. What do I mean? They might say, okay, well, what does y have to be in order for this to be a parallelogram? But they could give you this exact same problem and say, okay, y is a this is a parallelogram. What's y then, right? They can ask it either direction. They can say, hey, if this is a parallelogram, what is it? Versus, hey, what does this need to be to make it a parallelogram? Those two questions, with all the stuff we're talking about today, pretty much mean exactly the same thing, because these are definitions, right? And we talked about how definitions are biconditional. So going one way versus going the other way, we can do the exact same problem and have it be asked in two different ways. So just be aware of that. Don't be caught up with the language. Think about what they're asking about. So what we talked about earlier is that the opposite sides are congruent to each other. So I'm not telling you how you have to do it, but I will tell you, you've got these opposite sides that have the same variable. Why not start with those? They're the same. Find out what x is, right? Subtract 2x, then add 5, then you get x equals 6. So now I want to find y though. So let's use this equation. I know that y is going to be x plus 2. Well, what's x? Didn't I just find it? Right? It better be the same thing. So just plug that in now. So what's my answer? What value of y must we have in order for PQRS to be a parallelogram? Well, y had better be 8. If y is not 8, we can't have it. All right? So now I want you to give this one a try. All right, let's go over this one. So, I was saying be careful because there's multiple angle pairing methods. You can either set the opposite ones equal to each other, which you totally could do in this case and it would be fine, but like then you're dealing with a system of equations, and we're capable of doing that. We all took algebra 1. We're all fine with that. But why do that when you don't have to? If you take the angles next to each other, these have the same variables, you can add them together and set them equal to 180, right? Remember that the angles next to each other add up to 180. So, I mean, you could do it either way, and I'm not going to tell you no, don't do it using the system of equations. If you really like systems of equations, cool, do that. But like, if it's me, I'm only going to do that when I'm forced to. But like here, if I add angle E and angle H, I better get 180. So let's combine like terms and solve, right? Right, the y and the 3y make 4y, the 10 and the minus 2 make 8. Subtract. You know, minus 8 to both sides, right? And then divide. Let me 172 divided by 4, right? 4 does not go into 1, but it does go into 17 4 times, right? 4 times 4 is 16. Even goes with 1. Drop down the 2. 4 goes into 12 3 times. That's 12, right? So here, the value of y is 43. Then we can go back and do the exact same thing for x. So let's do that. 12x plus 7 plus 4x plus 13 also equals 180. Remember, we just take the ones that are next to each other, add them up, set it equal to 180. So let's do that. 12x and 4x, we've got 16x. 7 and 13 makes 20. Subtract the 20. So now we're left with 16x equals 16. 160, I mean, right? 180 minus 20 is 160. Gotta not forget the 0. But when you divide by 16 here, 16 divided by 16 is 1, so 160 divided by 16 had better be 10. So here we have our answer. Y is 43 and x is 10. Like I said, you could have done it with a system of equations, but if you don't have to, I'm a big fan of taking the easy way. Like if you can take the path of least resistance, do it. Here you can't. Here we know that the diagonals bisect each other. So that means that y plus 10 equals 2x minus 8, right? The length of KP and the length of PM are the same. We also know that x and y plus 2 are the same, the length of LP and the length of PM. So I'm going to go through and I'm going to say, all right, well, I already know that x is the same thing as just saying y plus 2. So anywhere I see an x, I'm going to replace it with y plus 2. So let's take this first equation and rewrite it. Y plus 10 equals 2 times x. Well, we just said x was what? Y plus 2, right? So anywhere we see an x, we just replace it with y plus 2. And now we can do what we need to do. We have one equation, one unknown, and we can just solve for y. And then eventually we can go back and find our variable x, right? So we got y plus 10. Going to distribute the 2 here, so 2y plus 4 minus 8. Well, let's simplify this. Y plus 10 equals 2y. 4 minus 8 is negative 4. And now let's solve for y here. Bring the 2y over here. Subtract the 10 from both sides. And then we can divide by negative 1. If negative y equals negative 14, then we know y here equals 14. Now, since y equals 14, we can go back and we can find x really easy. 14 and 2 make 16, right? So we found x and we found y. Now we have to actually find what km and ln are. Well, km is these two diagonals together. So let's figure out what each of these is. Y plus 10, well, y is 14, so this is going to be 24, right? 2x minus 8, well, okay. X is 16. 32 minus 8 had better also be 24. Now let's do the other one. LP is just X, so that's just 16. Y plus 2, okay, also 14 plus 2 is 16. So if I want to know what Km is, 24 and 24. And if I want to know what Ln is, it's just 16 and 16. So my two final answers here are this. So let's review a little bit. What did we do? First, we made our two equations. Then I was able to substitute in, right? Since I substituted in, I was left with one equation with one unknown. I solved for my one unknown. Then, having solved for that one unknown, I went in, plugged it back in to one of the equations to find the other unknown. And then I was able to plug that into the problem to get the actual answer that I'm looking for. All right? It's your turn now. Okay. Same exact problem, just different numbers, right? They're looking for PR and SQ. So let's get our X and Y values so that we can go through and do this. Let's set the two pieces equal to each other. We've got X plus 1 equals Y. We've got 3Y minus 7 equals 2X. And now we already have one variable solved for. We know that Y equals X plus 1. So anywhere we see a Y, we can just put X plus 1, right? So let's write this out. 3 times Y, well, 3 times X plus 1 minus 7 equals 2X. So now we've got one equation with one unknown we can solve very easily. Let's distribute. And here's a situation to watch out for, right? We talked about what happens when you've got just a variable or just a number on one side. Let that be already chosen, right? Let's take the 3x and subtract it over. So x here equals 4, right? So now you know x is 4. What does y have to be? Well, we know y equals x plus 1, and we know x equals 4. So y equals 4 plus 1, right? Y equals x plus 1. Well, x is 4, so 4 plus 1, which is 5. So now we've got our x and our y. Let's go back and actually get our answers. So x plus 1, 4 plus 1 is 5. Y, 5. Let's do these other ones. 3y minus 7. 3 times y, which is 5. So 15 minus 7, that's 8. 2x, 2 times 4, that's 8. So now we can answer our question. What's PR? 8 and 8. What's SQ? 5 and 5. Again, don't think too hard about this. Don't let this be something that causes you confusion and delay. You know, this should be very simple. Let it be simple. All right, let's do some more here. Okay, so parallelograms finished. Now let's get into trapezoids. So what is a trapezoid? A trapezoid just has one pair of parallel sides. The other two sides are not parallel to each other. So here we have some little names we call base angles. We call these two sides the legs. We call the top and the bottom parallel pieces the bases. And then right here, this one we refer to as an isosceles trapezoid. Isosceles, just like when we're talking about a triangle, an isosceles trapezoid, the two legs are the same size. And if the two legs are the same size, then that tells us that the bottom bases are the same, the bottom base angles, and the top base angles are the same. So whatever T is, that's what P is. And then 180 from T to R, right? So, if this is 50, R's got to be 130. But if this is 50, P is also 50. And A is 130. So the great thing about an isosceles trapezoid is that if you know one angle, you automatically know all four. Just like with a parallelogram. If you know one angle, you can find all of them. So let's talk about some examples. Here I know that angle C is 65. So what are the rest of these angles? Well, let's start with the real easy one. If C is 65, automatically we know that F is, right? These are the two bottom base angles. Notice the fact that you've got the top and the bottom side here are parallel. If this were sideways, you'd still have to follow the parallel lines, and you may need to tilt your head to the side to do that, right? Now let's do the other ones. Well, if this is 65, D has to make these two add up to 180. 65 plus what is 180? And if D is 115, automatically E is 115. Again, don't overthink this. Don't overthink this. The two angles on the bottom base are the same. The two angles on the top base are the same. And the ones on the ones that are in between the two parallel lines add up to 180, and the other ones that add up that are between the two parallel lines add up to 180. Don't overthink this. Let this be easy. Try this one. Remember what I said, this one may be tilted to the side, so you may need to turn your head. Alrighty, let's go ahead and do this one out. Once again, it doesn't help if this is sort of smushed to the side, but you turn your head, you can see which one should match up, right? On the top parallel, if this is 106, this had better be 106, right? They follow the parallel lines. Those are the same as each other. Now, if these are each 106, these had better be 74. Again, don't overthink these. Don't let yourself be scared by them looking a little bit different. It's just tilted to the side. That's all. Okay, here's a couple other things. With an isosceles trapezoid, again, isosceles only, because isosceles gets all that extra information. It turns out that here, how we talked about with the diagonals cutting each other in half with the parallelogram? Here, the diagonals are actually equal to each other. So if you know one, you know the other. And then the other thing that is true, and this is true for any trapezoid, remember we talked about the mid segment for a triangle where the middle one was half of the bottom? Well, now with a trapezoid, since we have a top base too, with the triangle, the top base was kind of 0 because it made a point, right? Well, here now, basically, the middle guy is the average of the top and the bottom. Now, they write it like this. They write it like this. And this, again, is a pain in the butt. Again, because you got that half and ain't nobody got time for that. I'm going to rewrite this. Top plus bottom equals 2 times middle. If you remember this one, it's going to be so easy. So easy. So make sure that you're doing the easy stuff. Don't do it difficult, do it easy. Easy, easy, easy. Top plus bottom equals 2 times the middle. It'll be so much easier than this. Don't do this way. This way's a pain in the butt, especially when you've got variables in there. Because ain't nobody want to deal with a fractional coefficient. Nobody wants to deal with that. Top plus bottom equals 2 times middle. This piece on top plus this piece on bottom, add them together. This piece in the middle, multiply that by 2, then set those things equal to each other, and then solve for x or whatever, and then you've got your answer. Don't overthink this. Don't do too much with these. Some of y'all are always trying to do too much. Make it simple on yourself. Like here, this is what I'm saying. If you tried to cut x plus 2 in half and have that be a 1/2, you're going to be miserable. Top plus bottom equals 2 times middle. Top plus bottom equals 2 times the middle. See how much easier this problem is? All you got to do is combine like terms, distribute over here. -10 and 8 is -2, right? Distribute the 2 here. 2x plus 2 times 2 is 4. So much easier to do. Look at this. Look at how much easier that was. And then, you look and you plug it in, you can see that it works, right? This should be halfway in between these two. Well, 3 times 4 is 12 minus 10 is 2. This is 8. So this would better be like 5, right? Well, what's 3 plus 2? 5. 5 is halfway between 2 and 8, ain't it? So you know you did it right. Whenever you got something like this, plug it in, see if you did it right. Always take that time. It's easy to double check that you're correct. It's so easy to double check that you're correct. Don't, it's like an extra 1 second of your time to do that, and it proves to yourself that you've done things correctly. Give this one a try. So once again, top plus bottom equals 2 times middle. Top plus lots of extra. Top plus bottom equals 2 times middle. Top plus bottom equals 2 times middle. So let's combine like terms on the left. We've got 10 minus 12 is -2. So we got 8x minus 2. Distribute here. 2 times 2x is 4x. 2 times 11 is 22. And then we're going to solve for x. Then add the 2 to both sides. Divide both sides by 4. 24 divided by 4 had better be 6. So we've taken care of this first part, what is x, and now we got to find what is mn. Remember I said it helps to plug it in because, sometimes that may help answer the question in the first place, but other times it's just enough to help prove to yourself that you did it right, yeah? So x is 6, well, 2x plus 11. 12 plus 11 better be 23. 8x minus 12, well, 8 times 6 is 48. Minus 12. And if you check, 23 is halfway in between 10 and 36, right? 10 plus 36 is 46 divided by 2 is 23. So we know we did it right. Hooray! All right, I think this is the last trapezoid thing, thank goodness. So basically what I'm going to do is I'm going to take that mid-segment thing and I'm going to sort of extend it out. And so the thing of it is, if I extend everything out and make everything all liney like this, don't get it twisted. This is a trapezoid. It's just they sort of made it look all messy, right? If we clipped off the ends, we would have a trapezoid. But the point I'm trying to make here, and the point that this is trying to make, is that if we've got all these parallel lines, and we know, the left side is the same all the way down all these pieces, then the right side is the same on all these pieces. Yeah, so if you know these are both 5, and you know this one is 6, well, you have to know that that's 6. If this is 12, this is 15. If this is 15, this had also better be 12. That's all it's saying, is that basically you know that it's cut into all the same pieces. So let me show you what I'm talking about. They're telling us that AB, BC, and CD are all 2. They're telling us that EF is 2 1/4. What does that mean about FG and GH? They also better be 2 1/4. Right? So now let's actually look at what it's asking. What is EH? Well, you better just add these together, right? 2 1/4, 2 1/4, 2 1/4. That had better be 6 3/4. Again, don't overthink this. Don't make this difficult. It's not difficult. If these are all the same, then these are all the same. Give it a try here. Make sure you can do it. Alrighty. So once again, they're telling you that each of these is 6. So that means that whatever A, B, B, C, and C, D are, they're all the same. They tell us the whole thing is 15. So what do these each have to be? Well, X, X, and X makes 15. So let me solve for X. So CD had better be 5. Okay, last thing, kites. So, and this should take no time at all because they're very simple. A lot less to work with. There are 2 things that you need to know. First is that kites have symmetry. Kites are symmetrical all the way through from nose to tail. Any angle you see on one side transfers over to the flip side. So if you know this angle is 10, this angle's 10. If you know this side has a length of 5, this side has a length of 5, etc. So all those things are the same. The only other thing to talk about is the fact that the diagonals make a crossbar, they make a T, that's a 90-degree angle. So when we deal with something like this, any angle on the right side or the left side transfers over automatically. So first of all 4 of these angles in the middle are 90 degrees. So automatically angle 1, 90 degrees. You don't even have to think about it. It's just true. Secondly, anytime we see an angle on the right or an angle on the left, you can transfer it over to its corresponding place. This guy's 52, so this guy's 52. Well, hey, 2 out of 3. Well, if this is 52 and this is 90, what's left over for angle 2 over here? What do the 3 angles of a triangle add up to? You better say 180. Then we can just combine like terms. So here, we know that this is 38 degrees. Give this one a try. See if you can do it. Same problem, it's just tilted on its side, but the exact same work. Okay, so same exact thing. Again, don't overthink this. This is 36, so this is 36. That's angle 3. All the angles here in the middle here are 90. That's angle 1. Angle 2, 90, 36, and what make 180? 54, right? Again, don't overthink this. These should literally take you 10 seconds to do. Don't overthink.